If you've been watching this channel for any amount of time, you know that I cannot turn down a new tool, and I'm always trying to learn every new skill that I can. And in this episode, I'm excited to say we are going to add CNC machining capabilities to this shop and to the F40 project. I've been wanting to build a car that is unlike its predecessor in pretty much every way, and I want to build the best car that I can, and this feels like we're going to be able to take this thing to the next level. And I've been able to learn how to do this stuff in a crazy short amount of time. If I can do it, you guys can too. Let's dive into it. Now this is going to be the most detail-oriented, techie, nerdiest episode that we have put out on this channel, I guarantee it. But you guys were kind enough to let me know in the previous F40 episode that you loved my CAD segment, it was your favorite part, and you want those nitty-gritty details. And this episode specifically is about my journey of learning how to do some basic CNC machining, because I don't know anything about this stuff, but I want to learn. It feels like the final frontier in building the absolute best cars that I can. And it's a dream of mine at some point to have a big, massive 5-axis mill in this shop where I can bust out any part that I can imagine. But that's always felt a long way off until this moment right now. And if I can learn to do this stuff, I'm convinced that any of you guys can too. So I felt compelled to put an episode like this together to tackle the entire journey beginning to end, because right now I'm really excited about what I've been able to make even within a couple of days of getting this machine set up. With that said, I want to talk a little bit first about 3D printing, because I feel like it's analogous to what we're going to be doing here today. When I was introduced to the idea of 3D printing, I was quite opposed to it because everything I had seen online required so much learning. You have to mess with these machines, you got to get them set up, you got to fine-tune them, you have to understand their inner workings, and I don't want a new hobby. I just want a machine that I can plug in, tell it to go, and have it produce a part for me. And I bought this Bamboo Labs 3D printer back here that did that job perfectly. It's been one of the best pieces of equipment I have added to this shop, and I use it on all sorts of stuff from our 244 GTK to the F40. I make pieces with it all the time. The question is then, is there a CNC machine that can do something similar? Carvera reached out to me and they asked if I had any interest in trying out one of their machines. So yes, to be clear, this machine was given to me, but I wasn't asked to give a favorable review on it. I want to give you guys my honest thoughts. We're not going to be making anything crazy on it. I don't know that it's capable of producing something truly nuts, but I think if I get crafty, this machine might be capable of some pretty cool stuff. And importantly, so far my experience is that I'm able to plug it in and start making parts almost immediately. So let me tell you about this machine, and let's start cutting some metal. This is the Makera Carvera Desktop CNC. It was designed from the onset to make CNC machining approachable, much like 3D printing has become. It includes features like an auto tool changer, an auto probe, a vacuum system, and even a laser engraver, so I think it's fair to say this thing is somewhat of a powerhouse given its size. A lot is included with the kit that we received, including an entire PCB fabrication pack. A lot of what this machine is capable of doing is producing PCB boards, but I'll be honest, I don't know anything about that, and I'm not sure I'll ever even get a chance to utilize these features, but it might work well for what you want it for. It also includes a lot of test materials so you can get your feet wet. Things like copper, acrylic, aluminum, and some wood, so you can see what this machine is capable of and how quickly you can get things made. It also includes everything we're going to need to start machining aluminum, including locating jigs, clamps, end mills, and tools to adjust everything inside of the machine. It also includes a 4th axis, so you know at some point I'm going to have to try my hand at making my own shift knob, but that's for a different episode. Now, for those of you that are really curious about the specs of this machine, here are some of the basics. The work area measures 14.2 by 9.4 inches with a 5.5 inch Z-axis, and the machine's footprint is 22.8 by 20.5, and it weighs about 110 pounds fully loaded. It's got a 200 watt spindle with a 15,000 RPM limit, It's got an 1/8 inch integrated collet, but has an optional 1/4 inch 6 and 4mm collets, and it will hold 6 tools inside of its ATC system. Spindle runout is measured down to 3/10,000ths of an inch, and the motor resolution is 2/10,000ths of an inch. Now, how that translates to part accuracy, I don't know, but I don't need to make any crazy pieces here, so I'm not too worried about it. All right, now that all that stuff's out of the way, I want to make a part. That's kind of the whole idea here, and that's what this machine is here for. I'm sure that's what you guys want to see. Now, I'm going to be honest. I have never done any sort of cam work before. I've never machined anything outside of what you've seen on this channel. I've never done CNC stuff. So, as somebody completely new to any of this, I've never written G-code, I've never written cam toolpaths, like nothing. How long did it take for me to get this machine up and running and to make a part? Because I have already made some stuff with it. We're technically going to be making a 3rd revision of a part. This is number 1. This is my first piece that I made on this thing, and it turned out really good. There's really only one problem with it. It's my chamfered inside edge. The bit was kind of offset wrong, I think, and it's kind of grubby. I think I had like the point into the part. I don't know how to explain it. I'm sure there's correct terminology, but I messed it up. I'd still run that. That's sick. I can't believe that I made that. That's nuts. This whole thing. It cut out the perimeter, did the holes, all the chamfering, everything. This is incredible. But there's always room for improvement. And I wanted to learn. I wanted to figure out what I did wrong, so I made a 2nd part. I made this one. I realized, oh, I could do a full facing pass on it, get a cool tool path on there, and I cleaned up my chamfered edges. This thing looks incredible. I'm so stoked on it. It looks awesome. I cannot believe that this is something that I made. Right here on this machine, right here in the shop, having never done any of this stuff before. Including the cut time, including the machine setup, including learning how to use Carvera's cam software. This is all in one day. Every bit of it, beginning to end. Setting it up, learning to use the software, programming it. I spent a few minutes drawing these parts up. This stuff's pretty easy. One day, day 1. Now we're on day 2, and I figured that's where we'd actually start the episode because I had to make sure I wasn't just going to like break stuff and make a mess and have no idea what's going on. So we're going to load this machine up with another piece of material. As you can see, I can fit 2 of these on one piece. So we're going to load this up. This is 6061 aluminum. We're going to get it set up in the machine. It gets kind of located thanks to some of their jigging they have here. It's going to probe, figure out exactly where the material is. This stuff's really cool. I'll show you. And then we're going to cut one more out. My main complaint, or my main improvement this time, is I felt like this still looks like a 2D part. I know it's engraved, but it feels like it's engraved versus like a cool machined from billet part. I'm going to call it a billet part, and I know some of you guys are going to complain about it. Deal with it. Billet parts. So we're going to go for it one more time. 3rd time's the charm. I've got a bit more detailing to it. I'm really excited to see how it turns out. My hope is this feels like a genuine CNC'd sick billet part. Let's put this machine to work and start talking about how it's all going to happen. So this is the model of the first fuel pump block-off plate that I made, and the second. The only difference is that I machined the top face for a better overall look. But I want to spice this part up and really make it feel like it's something machined, and so this is what I've done. I've added some pocketing so there's more than just 1 or 2 layers to this thing, and while that does make for a lighter part, that doesn't really matter in this case. I just think it looks like a more overall finished part with pocketing for the bolts and washers and pocketing in the middle, adding a 2nd layer that feels, I don't know, machined for lack of a better way to put it. This was a really simple model to make that translates directly from my experience with 3D printing, so I took this model over into Carvera's Carvera CAM software, which is what is used to design the tool paths within the CNC machine. Now, Carvera has a bunch of really helpful videos that allowed me to rapidly understand how this software works, and to put it in its simplest terms, it simply involves clicking the lines within the DXF file and telling it which bit I want to use and how deep I want it to cut. This is really simple 2D machining, and I'm going to guess this is as easy as it gets. An actual 3-dimensional complex part would be a lot harder to do, but this software will do it. I'm going to have to explore that in a different episode. Now, I know I'm glossing over a lot of important steps here about what these different tool paths do, and I'm going to touch upon them later in the episode, but the Carvera software makes this stuff really easy. It's got things like feeds, speeds, and materials all pre-programmed in, and I'm confident in saying anybody could do this. The Makera CAM software writes all the G-code for us, and then we send it over to the Carvera controller software, which actually sends it to the machine. That happens wirelessly. but you could use a tablet or something of the sort if you want to control the machine locally. I got our aluminum loaded into the Carvera and then set the machine off to do its thing. It goes through and automatically checks to make sure the material is level, and then picks out its bits and gets to cutting. Now, I couldn't really tell you what bit should be used for what. There's things like end mills and corn bits, engraving bits, chamfer bits, and while I have a loose understanding of how those work, I have absolutely no authority to actually choose any bits for any given job. And as said, thankfully the Carvera software helps me choose the appropriate bit for whatever I want to do. Most of this part is being machined with a 3.175mm end mill. It's the biggest one that I have on hand, and thus the fastest way we're going to remove material from our stock of metal. As for what materials this machine can cut, it's capable of non-ferrous metals like aluminum, brass, and copper, composites like carbon fiber, and of course pretty much any plastic or wood, but I don't think this thing's capable of cutting anything like steel or stainless. It's just too small of a machine, but honestly, I don't see a real need to cut anything like that, so I think it's going to work just fine for our use case. Well, it looks like it came out pretty well. I'm stoked on it. Doesn't look like we had any issues. So now just comes the part where we break it out of the material. So it's got these tabs that we left in. They're like really thin, so pop it out. Dude, let me clip these edges off and we'll take a look at it. Dude, that's awesome. That came out killer. I guess now the question is, does it fit on the engine? We gotta find out. All right, so now we finally get to like bolt this thing on and see how it's gonna fit. And to be clear, this is not like actually a finished part. It's not gonna be on the final engine because honestly, these pieces probably aren't even gonna be here, but how cool is it to have a CNC machined part? Like we made this here in the shop, subtractive manufacturing. Like this is insane. And here it is on this car, or on this engine at least. I couldn't be more excited for this. This feels unreal to me. The fact that, I know it's simple, it should line up, but the fact that the bolt holes line up, that the washers fit down in the pockets that we cut, like just how cool is this? This is something that I've wanted to be able to do for a long, long time. And I think being able to produce something like this in-house, while it's a very simple part, and it's not what I would call impressive, is just, I guess to restate what I said at the beginning of the episode, this feels like the final frontier for something I've wanted to learn, and I've officially got my feet wet. So, with this done, this finished part on the motor, I'm stoked. Let's start figuring out what else we can make. Before cutting our next part, we've got to get the machine cleaned out. It doesn't use coolant, but it does have an air assist to help keep the bit cool if you have it plumbed to shop air. And although it does have a vacuum system inside to gather chips, it's not really meant for things like aluminum, so we just let the chips pile up and clean them out when we're done. Now, as I get this next part clamped down in here, let's talk about this stuff. It's called wasteboard, apparently. There might be a different name for it, but given that we're not holding our part in, let's say, some sort of like chuck, and we're just kind of clamping it down to the work surface. This stuff is there so that we can cut all the way through the material without worrying about like cutting through and hitting the bed itself. So we're gonna get this stuff. It's literally called wasteboard because we're gonna throw it away. It's gonna go to waste when we're done. Sacrificial, if you will. We get it clamped down. This is clearly the biggest part that I've cut yet. Hopefully this goes well. It's kind of a bummer. If I had ordered material, granted ordering this stuff from McMaster-Carr, it only comes in specific lengths, but if I had ordered material that was, let's say, slightly longer, I could fit two of the same part on the material, which might have made it more worthwhile, but lessons learned in figuring out how to do CNC machining. Now, I suppose I should be careful in making sure I don't develop any bad habits because this is a hobbyist machine, and while there are a lot of parallels between this and something much bigger and more capable of actual part production, there are also a lot of differences, and I want to make sure I'm properly prepping myself for the future. All right, I think we're ready. Most complicated part so far. I'm going to try some text on it. Now I got to go write the G code. Let's find out how long it takes me. Anthony, what time is it right now? We'll hide his background. There you go. 3:19. It took 9 minutes in total for me to take the model from Fusion 360, pass it through the Carvera CAM software, get all of the G-code written, and send it to the machine so that it could start cutting the part. That's as an amateur that's still kind of figuring out what I'm doing, but it's also relatively a simple part. This is also just another block-off plate, but instead of being for the high-pressure fuel pump, this is for the intake ports on the cylinder head. Now, as we get this second part cut out, I want to dive into some of the further details. I want to further explain what's going on, what bits are getting used, and how this stuff works, because I think it's kind of important in understanding how to make parts like this, and because I want you guys that are more knowledgeable than me in the comments to chime in. I know I'm brute forcing some of these steps, and I've already realized looking back in this edit bay that there are better ways to do some of this, but that's part of the fun. I want to learn this craft, and I want to absorb all the knowledge that I can. Let's talk about the bits that I'm using. This project and all the projects so far are only using 3. First is that 3.175mm end mill, which is doing the work that you see here. It's the biggest end mill bit that I've got and that will currently fit in the machine, but I'm interested in upgrading to one of those 1/4-inch collets so I can remove more material more quickly. The other primary tool we'll be using is this much smaller 1.5mm end mill, which is useful for machining the lettering into the part. It'll also get the finer detail and sharper corners into the pentagon that we've been machining into all of these pieces too. Lastly, we've got a chamfering bit, which should be pretty self-explanatory. It's going to chamfer the edge, both inside and outside of all of these parts. Again, because all of this tooling comes with the Makera Carvera, it's all pre-programmed into the Carvera CAM software. I haven't had to establish any feeds and speeds, or really any other parameters at all, other than telling the part exactly how deep I want each profile to be cut. I went in order and machined the face, and then the pockets, and then the letters and pentagon. Each one was done in a 1.5mm increment for a nice, simple stepped finish. Now, with how much material there is on that thing and the size of that end mill, it's going to take a minute to cut, so I figured why not go in and install our other block-off plate, which I cut off camera. Now, if you're wondering how quiet this machine is, it is currently cutting in the background. I would call it rather quiet. We can have a complete conversation over it, we can record with a microphone while it's cutting, and while I can hear it, and I'm sure you guys can probably make it out in the background, it's pretty remarkably quiet. I was expecting something a whole lot louder, something that would just interrupt anything else happening in the shop and that we'd have to pause if we wanted to run the camera, but this feels like, given that it is a slow process to cut anything a size, it's something we can have running in the background while we're filming, and I think that's pretty neat. Now, I also cut a couple of other parts last night, these little block-off tabs that also look like keychains. Let me know if you want one, maybe we'll make some, that are gonna fit over some of these sensor ports that I just wanna close up while this engine is sitting here. It would be really cool for me to kind of learn how to do a multiple operation part where I can cut the backside of it and put an O-ring groove on it. I'm not there yet. I don't even know how to begin doing that process, but regardless, it's pretty sweet to be able to make something like this that could be used in kind of a final application as long as I wasn't trying to keep fluid in or something like that. And I think here in the next, few weeks or maybe even just a few days, I can probably figure out how to hold the part correctly so that we can actually put an O-ring on it, cut the backside of it, and make that a fully finished part that pops into place and would be usable on the track. So we'll see. I got to figure that part out. There we have it. That's definitely our most complicated part so far, but it turned out pretty good. Whoa. Pretty stoked on it. I guess now the question is, did I mess it up and will it fit? Let's clean it up real quick and we'll find out. I think as one final touch on this thing, and I could mess it up at this point, but I want to try putting some enamel paint down in the kind of like lower engraved portions, see if they like pop a little bit, see if it makes it look that much more finished. I'm not an artist, this could go very poorly. Here we go. Now, I'll be honest in saying I'm not the happiest with how this step turned out. I probably should have thinned the paint out even more than I did. It definitely needed a second coat, and it didn't dry with a really high gloss shine that I was hoping for, so I'm going to revise this step in the future, but I'm happy that I tried it, and I think that the look itself at least works out. I'm happy with it in that regard. It's also admittedly one of the more satisfying steps of this process. All right, that needs a little bit more cleanup, maybe another coat. I think next time I will thin the paint out more, but again, proof of concept. With that, this whole project is done, aside from the need for me to cut 3 more of these intake block-off plates, which is going to take a full day to accomplish. Again, these are really just to close off this engine while it's parked for the next, I don't know how long. I don't want stuff falling into this engine, but it was still a great place to start in learning how to machine some really basic parts that, yeah, otherwise could have been 3D printed, but it's hard for me to say 3D printing is anywhere close to this cool. It's also just a really simple part. I'm calling it 2D not because it's only 2-dimensional, but because I'm operating the entire machine off of a 2D drawing. I only have to explain things in the simplest 2-dimensional terms, and the machine figures out the rest. So I think that's going to be the end of our projects in this episode. And again, I do know that none of these are consequential. We didn't do anything meaningful with these parts. They're not going to stay on the engine. They don't serve a huge purpose over 3D printed parts, but that's not the purpose of this episode. And if you missed that, I'm sorry. But I am happy with what we accomplished. It's very clear that we can make some really cool stuff. And once I start thinking in the mindset of subtractive manufacturing and how to utilize a machine like this, I think we can build some pretty cool stuff. So what's my thought on this machine? Well, clearly we're not going to be making anything big and crazy. It is going to be somewhat limited with respect to how small the machine is, and then also the size of these bits. If we wanted to kind of make something sizable and of consequence, it would take a long time to cut. Our plate that we just made was about a 2.5 hour cut time. So you can take that for what you will. It's 3 millimeters thick, 3.25. So it's not a hefty part. Parts on this machine are going to take some time to cut. But with that said, it's clearly got a lot of capabilities, and that only scratches the surface. If you're into PCBs and making electronics, this thing is going to be a powerhouse for you. If you want to use the laser features, you can do sorts of like laser engraving. This machine does a lot for the money, and if you're a hobbyist and you want to make some cool stuff, I think that if you have that go-get-it attitude, you could make some parts and pay for this machine by selling stuff to your friends or firing up a small business in a pretty short order. Importantly, in my case, this thing feels like an incredible stepping stone as I venture forth and want to get my hands on a big machine. At some point, not anytime soon, but once I have some disposable income, I'd love to get my hands on a used machine of some sort, or maybe partner up with a company and get something in here that we can start making really big, nice billet parts on, and hopefully get them done in a little bit more of a timely fashion. Something like making my own control arms on a machine of consequence is kind of the dream. That's what I'd like to do long term. So with that said, this Carvera is pretty sweet. I'm really happy we've got into the shop. I'm going to be excited to see what we can kind of drum up, what other parts and pieces that we can make. I think little tabs and brackets, things like that, are going to be awesome on this thing. Are we going to be making center lock spindles? Absolutely not. So take it for what you will. I'm pretty excited about this. More than anything, this machine was worth its weight in gold in terms of how quickly I was able to learn a lot of CAM basics and kind of get this stuff figured out. I feel like I'm ready to take those next steps. This is pretty cool. Hope you guys enjoyed it. This was a nerdy episode, but it's a pretty cool outcome. We've got CNC parts here in the shop. So we'll have to see where it takes us. I'll catch you guys next week. We are going to be building an engine run stand for the V12. We're going to get it set up. It's an awesome project. I've been working on it behind the scenes for a couple of months now. Lots of fabrication, lots of welding. You guys are going to dig it. I'll see you next week.